Hey everyone, today we will familiar with a few terms which is related to UV visible spectroscopy. We know the observation of ultraviolet radiation results from the excitation of electrons from ground states to excited states. The nuclei that the electrons hold together in bonds play an important role in determining which wavelengths of radiation are absorbed. Hence, we can say the characteristic energy of a transition and the wavelength absorbed are properties of a group of atoms rather than electron themselves. So, the group of atoms producing such an absorption is called a chromophore. Such group generally possess unsaturated centers or heteroatoms or sometimes both. For example, C double bond C, C triple bond C, C double bond O, and the carboxylic acid group COOH, nitro group NO2, diazo group N double bond N, and cyano group C triple bond N, etc. are examples of chromophores. Whereas an auxochrome is a functional group that does not show selective absorption above 200 nanometer on its own, but when present along with the chromophore, it causes a shift of absorption to longer wavelength and an increase in the intensity of the absorption peak. Groups such as OH, NH2, OR, NHR, NR2, SH, etc. function as autochromes. Change in the pH or the effects of solvents or even the substitution of a hydrogen in a chromophoric group often cause shifts in the position and intensity of absorption peaks. Based on that, there are 4 types of shifts, namely bathochromic shift, hypsochromic shift, hyperchromic shift, and hypochromic shift. A bathochromic shift or redshift can be defined as a shift of absorption maximum or lambda max to longer wavelength. For example, benzene shows a lambda max of 255 nanometer, whereas aniline shows a lambda max of 280 nanometer. Here, the introduction of an auxochromic group, that is the NH2, upon the benzene ring brings about a bathochromic shift. Whereas a hypsochromic shift or blue shift is known as the shift of absorption maximum to shorter wavelength. For example, aniline shows a lambda max of 280 nanometer that we have mentioned already, and if we add an acid to aniline, it yields anilinium ion, and which shows a lambda max of 254 nanometer, thereby causing a hypsochromic shift. A shift of molar absorption coefficient epsilon max to a higher value by an increase in the intensity of an absorption band is called a hyperchromic shift. For example, conversion of phenol to phenoxide ion shifts epsilon max from 6200 cm inverse to a higher value of 9200 cm inverse. Actually, a bathochromic shift is accompanied by a hyperchromic shift. If epsilon max shifts to a lower value, depicting a decrease in the intensity of an absorption band, then it is called a hypochromic shift. For example, conversion of this benzoic acid to benzoate ion shifts epsilon max from 11,600 cm inverse to 8,700 cm inverse. Actually, a hypsochromic shift is often accompanied by a hypochromic shift.